Hello everybody, welcome to Pandas Complete Tutorial 2021. In this tutorial, we're going to learn everything you need to learn to get started with Pandas data preprocessing. Okay, so at first to begin your data science journey, you at first have to import Panda library. So we are going to import our library by import pandas as PD. So it's just actually a scientific convention to import pandas as PD. If you import pandas as TF, it would be a bit weird. So people can't read your code. Not many. I think people can't read your code easily. Okay, fine. So we have imported our library. So the next step is to read our data. So we are going to read by just pd dot read. So we are accessing pandas functions or methods by just writing this pd dot. Okay, pd dot, and if you now hit the tab button, you will see all the associated methods in this pandas library. You can see lots of methods in this pandas library. Okay, so pandas dot read. If your data is a CSV file, then you have to write read CSV, but if it's Excel file, then you have to write XLS. Pandas dot read Excel, then in a parenthesis, in a comma quotation, you have to write the name of your data Excel file. So my file is water quality, and after that you have to write the extension of your file. So it is XLSX. But if you are reading a CSV file, you have to write here .csv. Okay, fine. So I'm going to store this data in a variable like df data frame. So data loaded. Now if you want to see the data, this is our data df. Fine. So we normally we read our data by df.head, which will provide you just first 5 rows, and if you write df.tail, then it will return you the last 5 rows, and if you don't pass anything, then just the first 5 and last 5. So a total of 10 rows are in front of us. Okay, fine. Now we are going to talk about data structure, which is really an important one if you are going to start your journey in data science. So pandas, there are two kinds of data structures in pandas. One is pandas data frame, another is pandas series. So now what you can see here is actually a pandas data frame in a tabular format. Now and each of those columns are actually pandas series. If you extract one column, then it will be a pandas series. We'll see that. Now pandas data frame is actually two-dimensional, essentially two-dimensional. That is, it contains one column and one row. So first dimension is our row, second dimension is our columns. You can also see them by just what, if you see df dot shape. Okay, it doesn't, it's attribute. So 64 17, it's telling us that along our first dimension, that is row, we have 64 elements or 64 rows, and along our second dimension we have 17 columns. Okay, so now you can see the dimension of df dot ndim. is two-dimensional, our data frame. And you can also see the type of this data frame, typ type, and within the parenthesis is our data frame. So it is Pandas core frame data frame. So this data frame is actually what is heterogeneous in nature, could be heterogeneous in nature. That is, one column can contain floating points, another column can contain strings or integers, so it could be heterogeneous. But Pandas series is homogeneous in nature. It's like if you put one string value in this column, then the whole column will be interpreted as string. Okay, so they are homogeneous in nature, Pandas series. Now let's see Pandas series. Actually, df, we are extracting one column like manganese. Now you can see that whenever you extract a column from Pandas data frame, our two-dimensional Pandas data frame goes down into one-dimensional Pandas series. This is one-dimensional Pandas series. Okay, and it is homogeneous in nature, that is float. Okay, so now if you can see dimension and the number of dimension, so it's one dimension, and also the type, typ type. Fine, it is Pandas core series. Okay, and if you see our string column union, okay, our union. So this is actually Pandas object, series object. So Pandas series objects are actually string values, but not always they have to be object. Objects are sometimes could be something else in special cases. Okay, so and this series contains similar types of data, and this vectorized form gives Pandas series higher computational power. Okay, and what is vector? Vectors are actually n by 1 or 1 by n matrix. There is either one column or one row of a matrix. So that's all about, I think, data structure in Pandas. So there are two data structure. One is Pandas data frame that are heterogeneous in nature, could be, and another is Pandas series. And notice one thing here: Pandas data frame contains always two index. Now here one is a column index, that is our column names. Another is our row index, that is by default our 0, 1, 2, 3 index, and you can change it by just specifying index column is equal to 0, 1, etc. But in the case of series, it only contains one index, that is our row index. Okay, so series contains one index and data frame always contains two index. Okay, so that's all about Pandas data structure. Okay, now that we have talked about data structure, it's time to talk about indexing and slicing. Okay, fine. So there are couples of many ways you can index Pandas data frame. So the first one is dictionary like, and we often use this dictionary like access, that is using this square bracket syntax. So within this square bracket, what you have to do is you have to write a quotation, and in quotation you are going to pass the column name you want to extract. So let's say I want to extract my manganese calcium column concentration. So now this is our Pandas series, just one column. So now in case you would like to extract two columns, so that is list of names, two or more columns, So within this square bracket you have to write another square bracket, and now in the square bracket you can pass your desired column name, that is list of columns. Okay, that should be in different. Okay, fine. Now you can say this is a data frame. They have a column index and as well as a row index, so it is actually data frame pandas. Okay, now there's another way of indexing is just df dot the column name like calcium. Okay, but this method is sometimes ambiguous, because if let's say you have a column named shape, so if you write here this shape, it will not return you your column, because shape is pandas built-in attribute, so it will give you just the shape of the data frame. Okay, so it's good to use that square bracket syntax, I think. Okay, so now calcium. Okay, now this indexing is actually case sensitive. Notice here I have written this calcium C. It's actually uppercase letter, that is capital letter, but if you write it in just CA, it will return you an error, that is you don't have any CA in the data frame. Object has no attribute calcium. Okay, so what you have to do is calcium. Okay, now it will be okay, fine. So now there's another method of indexing is using iloc or LOC, that is locator accessor, and it is quite popular one, a common one. So what we are doing is df dot iloc, and again our square bracket syntax, and within this syntax what we are going to do is at first we are going to write a comma. Okay, so left side of this comma means our rows, and the right side of our comma is actually our columns. So we are going to index or slice. By left side is we are going to slice our rows, and by right side we are going to slice our columns. Okay, fine. Now let's see how we do that. Let's again print our data frame df dot ahead, no need df. So let's say we want to slice first 4 rows and what these first 3 columns. Okay, so df dot iloc. Okay, fine. Let's try single, that is single row, single column. Let's say second row and third column. So third column we are providing 2, because first column is 0 index, second one is 1, and this third column is index 2. Fine. So let's see what it returns. It should return this one. Okay, now yes, ambiguous. Now if we pass the last index, the last row, that is -1, so it will give us this one. And if you use the LOC, we'll talk about that later, then it will not work actually, because LOC works on level based, and we don't have any -1 level here. We have 63 level but no -1. But iloc work on index. Okay, so let's see what it returns. See, Aliyabad. Fine. Now let's do it for multiple columns and rows. So let's say you want 2 to 4, so 2 to say 5 2 to 5. So this will not include fifth row, comma, first three columns. So this, for range of columns or rows selection, you have to use this colon syntax or colon character. So 0 to 2. So 2 will, second column will not be counted, that's why we have to write 3. So now let's see. So you can see the second index, that is union, but third index not, sorry, third index not included, 0 to 3. So this is our 0th index, this is second one, and this is second. So second index included, but third index was not. So if you write here 0 to what, 0 to 10, then it will return 0 to 9 actually. So this happens in Python for selecting range of values. Okay, but here if you are going to start from the 0th index, you don't have to write this 0. This will return same thing. Okay, now let's say you want third index to the end. So just after 3 you have to put that colon syntax. Okay, now third is actually included because this is the initial one, but last one will not be included. Fine. So this is about ilog. Now if maybe you want all the rows, so all the rows means just this syntax, this column. Okay, now all the rows and columns from our third index. Okay, now let's talk about div.loc. So LOC works on actually label based works. Let's say you want all the rows and just this bicarbonate, Control C, so just V and what, and our calcium column, these two column. So to put, at first just say bicarbonate, okay, but if you want more than one, then you have to embed it within another square bracket. Okay, so within this square bracket you have to write, you can write as many as column names you want. So Control C, within a quotation, Control V. Now you will have all the rows and only those two columns. See, this is now just a data frame. And if you want just 2 to, for 2 to, let's say, 9th rows, then it will return that. See, so that's, now these are just our defined things. How about Boolean indexing? If you want, let's say you want to know calcium concentrations, you want all the rows where calcium concentration is, let's say, more than 88 milligram per liter. Okay, so how can I do that? So what we will do is Boolean masking. So df.loc, we are now using loc because we will pass column name. So again df dot column name, that is our calcium. Okay, and you can also pass, or you, the same thing is just within a square bracket syntax, column name you want. So you want concentration greater than what, let's say 88 milligram per liter. Okay, so let's see how it turns out. Fine. So it returned all the rows which have calcium concentration more than 88. So you can see all the rows have calcium concentration more than 88. But this is actually, here you can say that this is actually for rows. Now if you write a comma and pass column name, that is our calcium, within a quotation, now this will return you only the calcium column for concentrations more than 88. See, and you will use this method in your work, I think, in future. Okay, so that's all about Boolean indexing. Fine. So how about multiple conditions? Let's say you want calcium concentrations more than 88 but less than 150. So two conditions. How do you do that? So for that, what you will do is, like, again, write div dot loc. Okay, so in a square bracket, what we will do is we'll use this. This is our first condition, and this will be our second condition. Okay, within this square bracket, within this bracket, sorry. So this bracket we are going to write df our column name, that is calcium. Okay, now calcium is greater than what? Greater than 88. Fine. Now, and within this parenthesis we'll write what? Again, df our column name, calcium. You can pass something else, I mean other column name also. Okay, df calcium or manganese less than or equal 120. Okay, so we want calcium concentration more than 88 but less than or equal to 120. So let's see. Okay, say all the rows where calcium concentration is below 120 and more than 88. But if you want OR operator, that is either 88 or 120 in between, so you can write this pipe operator, okay, this is OR, all elements. Fine. So that's all about our indexing and slicing, I think. And one thing I would like to add here is, what we have done here, this thing, we can do the same thing by another method, that is a string method. So how can I do that? Is df dot, oh no, we don't need that actually because it's not a string column, but if it's a string column we can do that, like union. So here we have our union name, that is a string Pandas series object. So let's say we want all the rows for where union name is equal to this Aliabad. Okay, fine. What it is return? Fine. So df dot loc. Okay, fine. So this returns us all the columns which are rows where union name is Aliabad. So the same thing you can do by just commenting it out. By what? By df dot union dot str, this string str accessor using. We'll talk about this str accessors in detail in the later part of this video. Okay, str dot what contains, TAILS contains what, contains in quotation we write this element. Okay, now let's see. True false, it's actually boolean, so just embed it within a square bracket and again div. Okay, fine. Now I will see that those column names. Fine, so this also returns us the same thing. Okay, now you can also write here regular expressions like caret sign a, that is I want all the column names that starts with a. So this dataset is small one, it's not, this method will not work good. So you can see that we have two different names that starts with a, I think. Yeah, so this rejects regular expression methods really powerful than boolean, just boolean operation. We'll talk about them later more. Okay, fine, so that's all about our indexing and slicing. Now, oh, I forgot to talk about some of the basic things like div.shape. We know what it returns, just our length. This is our length of data, that is the length div 64. So this shape method returns us row number and column number. Now if you put in a square bracket 0, this will return as the first number, that is 64. Okay, now okay, you can see 64. But if you write 1, it will return 17, second element. Okay, that's it. And we can talk about div.describe. This will give us mean, standard deviation, 25th percentile, 50 percentile, 70 percentile, everything for all of the columns that are integer or float. Okay, you can see bicarbonate's mean is 541. Okay, it will be more easy to read by just transposing. Now it's more readable, I think. So for calcium, standard deviation 35, mean 25 percentile means 25% of our data lies within this concentration limit, and 50 means 50%, that is 50% means median value. So our median value, that is 50%, lies within this concentration and 50% lies above this concentration. Okay, so it's a bit handy. So we talked about describe, and again another thing is div.info. Info will return your data type, that is which column is which types. So latitude, longitude, floating point, union, object, that is a string, all of those are float. Now if you would like to know a specific columns and data type, then what you have to do is just .dtype. Okay, it will return you the data type for that column. Okay, now you would like to know unique values. Let's say div.union.unique, QUE. What it will return you is just all of the unique names within this union column, and this union column represents actually location name. Okay, so we'll see how many locations we got. So these are the unique location names. Okay, fine. So now let's say if you want to know how many unique names are in there in this list. So what you have to do is just dot shap shape. So we have 12 different location names, and in a square bracket if you pass just 0, it will give you the number, that is unique names. Same thing you can do for our floating point variables like df dots calcium dot unique QE. Okay, so here we have unique concentrations and dot shape 0. So out of 64 samples, we have 57 unique values of calcium. Okay, that's all about unique. Now what I can do is again df dot head. Fine. So let's say we want to rename one column. This is union name. I want to replace it by what? By location. So how can I do that? df dot rename, and you can see the associated parameters this method takes by just writing by just holding shift and press tab. Okay, now you can see this provides us all the parameters associated with this method. So it takes mapper, index, columns, axis, in place. Okay, so what I want to do is rename columns, COLUM, columns equal, and now here you have to pass a dictionary. What dictionary? What do you want to replace? This is union. Okay, then this column and what now? And by which name you want to replace it? So I want to replace by location. LOCATION location. Okay, now let's see. Now you can see this is our location. Okay, fine. Let's see if it is updated. So if oh, now you can see over here. Now it's again our previous data set. This location is not updated. So rename, if you want to rename permanently, then you have to assign this in place equal true, or you can do just right here df equal and cut it. So if you again reassign the data frame to your previous data frame on any new variable, then you wouldn't have to write in place. But if you don't want to do that, then you have to write that in place equal true. Okay, let's see. Fine, now you can see our union name is replaced by our new name, that is location. Okay, so if you want to rename all the column names, so what you have to do is df dot columns equal, now you have to give list of names, like for the first one what you want to give. So you have to write all the column names again. So by this way you can do that, but I'm not going to do that it again. So now let's talk about some Pandas built-in mathematical functions like min, max, mean, standard deviation, mode. Okay, so math. Okay, so let's say df dot max. so it will return your maximum values for all the columns. If you pass here minimum, min, then it will return you minimum values for all the columns. Okay, you can see arsenic 0.041 microgram per liter. So if you want to okay, now df dot mean, mean, that is central value. So maybe you want it for just one single one single column. So how do we do that? So df dot, let's say arsenic not manganese dot max. That's how you do that for a single column. And sometimes we want to return our mean, max, standard deviation, minimum all at once. So you can also do that by just using our aggregate function. So df dot your column name, then dot aggregate function, then what? Then a parenthesis. So within a parenthesis, we are going to pass a list of name. So one is our mean, okay. Another is our what? Our standard deviation, STD. Okay. Now let's print it. Now you can see they're returned at once. So mean is for manganese, mean is 0.65. Standard deviation 0.72. So you can say that this data is actually skewed, and you can also see the skewness of data by just writing df.skew. So yep, so yes, manganese is positively skewed, some of them are negatively skewed. We'll talk about skewness, data distribution normally, or if positively skewed, and how to fix them in another video, I think. Yep. Okay, you can also, and skewness of greater than 0.78 is not good for linear algorithms. You can also see the kurtosis, df dot KER kurtosis. Okay, up. Okay, it's kurtosis, KUR. Okay, so kurtosis actually tells us about the distributions top, I think, structure of the top. Okay, so that's all about some mathematics. Now let's talk about groupby method. Pandas, a very popular one, groupby method. Okay. Fine, so again we're going to see our data frame df, and we want to group by our data set by locations. Okay, so before we talk about group by, let's say we want to drop some columns, so unnecessary columns. So latitude, longitude, I don't need those columns, so I can drop them. So to drop them, what you have to do is df dot drop, and now we have passed the column names. Okay, first one was latitude degree, control C, df dot head. Okay, control V, and another is longitude. Okay, now here you have to again write axis, that is how you want to drop it. So if you write 1, then we are telling pandas that we want to drop by columns. But if you want pass 0, then it will drop by rows, and there is no row named um, latitude or longitude, so it will return you an error. And you can also pass in place equal true, like the previous method. O axis drop dot multiple values for argument axis. Those ugly messages, huh? So we can't pass multiple values at a time. So to pass multiple values at a time, you have to embed it within a square bracket. That is, we are passing list of names. Okay, that should work now. Fine, cool. Now div dot head head. Now you can see now latitude degree, longitude degrees are gone. They dropped. Fine. We'll talk about that drop method for missing value removing in the later part of this video in detail. Okay. Now let's talk about our group by method. So div dot group by group by what? So we want to group our data by our location. So in a parenthesis, the location. Okay. Now location dot what? Dot you have to pass a method. So dot mean or sum or anything. You should write at least some method. Otherwise, it will not return you anything. So div dot group by location. That means let's see. Now it returns us location based mean values for all the water quality parameters. Okay. Now if you want, you can plot it. Dot mean dot plot. Okay. See, this is actually a line plot. I want a bar plot, so kind is equal to what? Is equal to bar, bar. So yes, so this is actually, this plot is interactive plot because I imported matplotlib notepad. I don't know when I did that, but so just what you have to do is, and I don't like pandas inline matplotlib inline plotting style. So what you have to do is import, just write %sign matplotlib notebook notebook. Okay, so then you will see such interactive kinds of plots. Okay, so you can zoom it if you would like to. Now you can see the x y values in the right hand side corner. This is for 9.47. okay, we don't need them right now. So okay, you can plot it. Now div dot group by, now div dot group by, you can pass multiple columns. Let's say you want by location, LOCATION location, and group them by what? By well depth. So well depth should not work. Let's see. Yep, well depth. So you can pass more than one values. So to do that, if you are going to pass more than one value column name, then you have to give a square bracket, that is we are passing list of names dot mean. Okay, so now you can see the mean values by well-depth location, and you can also see the index. Our index now changed by group. Okay, so let's say I don't want more than one, just one, and I want my output only single column. So what you have to do is just write the column you want the output for. Okay, calcium. So now this will return you mean values of calcium by location labs. Fine. So you can here also write that aggregate function, and here write so mean, then let's say a standard deviation. Now plot it. Fine. You can also plot it. Now you can also group them. For example, you want to know let's say how many calcium samples are taken from each location. So counts or number of calcium samples from each location. So again we'll group them. So df dot group by location, and we want our output for only calcium column. Okay, dot dot what, dot count, after that what, dot count dot let's see what it returns. Okay, that's it. So we can say for Aliabad this location 7, and maximum samples are taken for this location. Okay, you can also plot it. Okay, oops, you have to write plt dot figure because we are using matplotlib notebook instead of inline. plt. Oh, okay, so to fix this problem we just need to import matplotlib as plt. Now it should work. Yes, and I want a bar plot, so kind equal bar. Fine. So this is actually an interactive plot. You can see the amount here is 12.94, so that is 13. Okay, and zoom it if you would like to. So you can see 13. Yep. So that's all about this group by method. Okay, fine. Now let's say you want to create a new column. So how can I do that? So let's say I want to create a column df.calcium, which will contain percentage of calcium concentration for each station. So df.calcium divided by length of what, maybe sum of df.calcium and multiplied by 100. So I want to give it a name. So what will be the name? So in a square bracket we will give our new column name. So let's say percentage TAG percentage calcium. Okay, let's see. Fine. Now div. Now you can see here we have our new column name, and we will see that we will create some other new columns in our following tutorial. Okay, now let's talk about apply method. Replace method. Replace. Okay. So Pandas gives us this replace method, df.replace. If you would like to replace any value by your desired one. So now you can see that the first argument or parameter is to replace. So which one I want to replace? Now for example I can say I want to replace 0.111 values by 50. So to replace 0.1 and value is 50, and in place is just if I would like to replace it permanently. Okay, regex is regular expression. So this replace method allows us regular expression when you are going to replace some strings by another string. Okay, you can use str accessor or regex equal true. Both will do the same thing. Okay. So now let's say I want to replace manganese. The concentration of sulfate, arsenic. I want to replace this concentration 4 by let's say 50. Okay, so df dot column name arsenic dot replace, then I want to replace 4 by 50. Okay, now let's see. Now you can see that it was previously 4, now 50, now 50. Okay, so if you wanna change it permanently, then in place equal true. Otherwise you don't need to do that. And one another thing is that you can pass a list of values, like you want to replace 4 and let's say this first one 990 and 7 by by another list, 4 by 50, 990 by just 100, and 7 by 0. So now let's see how it starts out. Yep, it worked quite successfully. Now you can see it was previously 7, now replaced by 0, 990 by 100, and 4 by 50. Okay, that's all about replace method. We'll see that replace method more in the previous tutorial. In the following tutorial. Okay, that's all about replace method. Now we are going to talk about apply method, which is a bit advanced one, and it's pretty useful one in data preprocessing, and it's quite fast. Now we are going to just start off by simple one, like div dot location dot apply. So before you apply this method, what you have to do is just extract that Pandas series on which you want to apply something. Okay, fine. Now let's say I want to know the length of all of those strings, location names. So you have to just write len, alien. You don't have to write that parenthesis after this length function. Okay, let's see. Oh, you can also store it in a new variable like df at alien. Now see our data frame. So this location name containing 19 words, a character, and this one is 7 character. Fine, this is just a pretty simple one. You can do the same thing by df dot location dot str dot alien length. It will return the same thing. So we wouldn't apply that method for that simple task. Basically, apply method is pretty useful and popular for passing a defined function or lambda function, and we will see that now. So let's say I want to create one new column based on this arsenic concentration. We want to write where arsenic concentration is less than 10 is good for drinking water, and where concentration is greater than 10 but less than 50, we'll say that is not good, actually poor quality, water quality. And if concentration is greater than 50 microgram per liter, then it's bad water quality, unsuitable for drinking. So how can I do that? For that, first we are going to define our function. Function name, let's say func. Okay, now here our column name, concentration, CON. Fine. So if concentration is less than 10, then what we will return is return. Return what? Return good water quality. Fine. And if concentration is greater than 10, and concentration is less than or equal to 50, then what? Then we would like to return what? And you can just embed it inside a bracket for just readability. Okay. Return what? Return poor. Okay, and else if concentration is greater than 50 milligram per microgram per liter, then else return what? Return unsuitable for drinking. Unsuitable. Okay, so let's see how can I pass this in this apply method. Now df dot arsenic, in which column you want to apply this method, with that column name here, df dot arsenic dot apply what? Just the function name, nothing else. func. Okay, let's see what it returns. So you can say it's successfully executed. Good. Now you can also store it in a new variable, df water quality Q. Now let's see our data frame df.head. Not it. Let's see. Now you can say arsenic concentration less than 10, so it's good, and it's more than 50, so it's unsuitable. So it's really good for data pre-processing and easy to perform and time saving. So now you can also do the same thing using just a lambda function. Okay, let's see how can we do that. But to execute or pass this whole function in lambda function is a little tricky. So at first we will try a simple one. So what we have to do is copying this one. Okay, let's see. Dot apply what? Lambda function. Lambda. Now you have your expression. You can write anything you want, x, y, z. We are just going to write concentration. Okay, then colon. Fine. So if our concentration is what? Less than 10, then what we will return is good. So GWD. So notice here I write at first if concentration is less than 10, then before that if statement I have written what I want to return. So yeah, good. Okay, fine. Now else what? Else just write poor. Okay. So lambda functions are actually limited. You can't pass elif statement within lambda function, but you can do that by using some other, just using a bracket. We'll see that in a minute. Let's first try this one. So it worked. If concentration is less than 10, then poor, good, and else poor. But if you want to do the same thing we did above, here that is elif statement, this, what you have to do is you have to write here, a bracket, and within this bracket we will write, let's just delete this poor. If concentration is greater than 50, so 10 and what? And less than or equal to, concentration is less than or equal to 50, then what we want to return? We want to return it's poor. Okay. And else what? Else unsuitable. Unsuitable. Okay, so you can see our lambda function is actually finished here. We extended it by just using this parenthesis, this bracket. Fine. Now let's execute it and store it in a new variable df lambda. Now let's see if it's equivalent to the previous one. What happened? Oh, another bracket. Fine. Now div. Now you can see over here that it's the same thing. Good, good, unsuitable, poor. Same thing, just within one line. So you don't have to write one defined function explicitly. Okay. Now we can do many more things like div.head. let's say I want to scale this data. So what I want is I want to subtract mean from this data, mean from all those data points. Okay, so that is data centering or scaling. So how can I do that? Using a Lambda function. So, and this process will not occur on those string columns, so we have to drop them. So df dot drop location x is equal to 1 dot apply word lambda expression of x. Now what I want to subtract mean from this x dot mean. Fine, let's see what it turns out. Fine, so it scaled our data. pH 0, nil of them are 0.0 something, but which are skewed highly, they are not very well performed. Okay, so quite simple one. Fine, now another thing I can do by this applied function, which is quite powerful one. What you can do is, at first I'm going to make some null values. df dot replace what? For example, I want to replace this 94, 74 by NaN values. So giving a list 94, 74, I want to replace them by np dot nan. Fine, and in place equal to. Okay. So we don't have to modify it again. Now you can see some NaN values, and I want to input those NaN values, replace those NaN values by the mean of arsenic, but not just mean. We want to replace them by location based mean. So you may have different means for different locations. So how can I do that? So that we can do that by lambda function on this apply method. So df dot column name arsenic dot apply. What we would like to apply is lambda. Also df dot arsenic, df dot groupby arsenic df dot group by what? Group by those locations. I want mean of arsenic by locations. So LOC location. Then on which column I want the output. I want the output on just this arsenic column. Fine. Dot apply lambda x of what now? So x of x dot fill array. Okay, now so fill array is also a method. So within this method, what we want is x dot mean or median. Fine. So let's see. Yes, quite successfully occurred. So you can see here our last 4 values are NaN values. So now last 4, this is 22, this is 3334. So those are different because locations are different. Alright, so now in this section we are gonna be talking about missing value handling with pandas, and this missing value handling is actually quite common one actually in data preprocessing. Okay, so at first we just imported our necessary libraries, then our data set. It's actually a big data set, we'll talk about it later. At first we're gonna start with a simple one. This one. So this is a pretty small data set, so you can visually see missing values. At the first task here is you finding your missing values. So what you have to do is df.isNA is any missing value. So it will return you a Boolean, true false. True for yes, it's a missing value. Then dot sum if we want to know how many. So in a B column we have one missing value, and in C column we got two missing value. Now that we have identified our missing value, it's time to replace them or drop them. Okay, so pandas contain a very cool function called fill na. Oh, sorry, drop. First you can drop it, drop na function, and if you pass it, it will drop your missing values by actually rows. Any missing value in any column will be dropped by this method by default, but you can also pass axis here. Axis by default is 0. If you pass 1 or column COLUMNS, then it will delete or drop those columns which contains any missing value. Okay, fine. And you can also find out associated parameters within this method by just holding shift key and pressing tab. Now you can see axis which could be 0 or 1. By default it's 0. How? We don't need how. This threshold is very important. We'll see that in a minute. Subset in place. In place is actually for, now if you write again df, you will say df is not updated, missing value still exists. So to modify update it, we have to pass in place to true. In place true. Now you see our df is updated. Cool. You can also fill those missing values by fill na method. So that's like df dot fill na. Now here you can pass like 0 or any number you want, or like df dot mean. Okay, now our missing values will be filled by mean of those columns. Fine. You can also use some methods like met. Methods method. It could be forward fill or backward fill if fill. So now pandas will use the previous value as the valid value to fill that nan value or missing value. Okay. Okay, there's another function called replace function, which is also pretty useful in handling missing values or replacing any value in your data set. So it's just df dot in replace. Okay, so what do you want to replace? We just want to replace 5s by let's say 0. See, all 5 are now turned to 0. There was a 5 actually. Again, now just see 0 0. Okay, that's it. You can also pass multiple values in replace method. Fine. Now let's talk about our large dataset. Fine. Here you can see 5 columns, and if you want to see the length, div.shape 1460 rows and 81 columns we have got. Okay, now we want to see missing values of this dataset. div.is na.sum. Fine. And we want it as percentage format, so we divide them by length of our dataset and multiply them by 100. Close them in a bracket. Okay. And we also want to sort our values. So sort values. Yes, values by what? By ascending, false, descending order. Okay. Store it in missing columns variable. MSK. Okay, MSK. Now you can see all missing columns and missing values in percentage format. 47 of data is missing. 80% of the data is missing for this column fence. Okay, and we can see just first 20 columns. Okay, now you can see a total of 19 columns have missing values, while these 2, 4, 6 columns have very high missing values, 17% to 99.52%. Okay, so we don't want all missing columns, we just need those have exceeded more 10%, those who have more than 10% missing values. Okay, so MSK is equal to MSK and more than 10. Okay, now missing columns more than 10 are these columns. We just here created a mask actually. And we don't need those columns associated with values, we just need their name index. Okay, fine. Now we want to drop those columns from our dataset. So df.drop what? Drop df and pass those column names MSK. Cool. And X is 1 or column, same thing. And here you can write in place equal true, or just reassign it to new variable or old variable df, same thing. Now df, let's see, oops, what happened? Okay, it's okay now div.shape tuple object. Oh, it's attribute 17 columns. Previously we had 81 columns, now we have 71 columns. We have successfully dropped those highly missing value containing columns. Fine. Now we'll talk about threshold method. this threshold parameter is really a excellent one, really. Div dot drop na. Okay, x is equal 1. Okay, fine. And thresh threshold equal. And what does this threshold mean? We are here specifying that if you pass 2, that means keep those columns which have at least 2 non-missing values. Non-missing, it's not missing, it's just opposite, non-missing values. So previously we did what? We dropped those columns which have 10% or more missing values. So that is, they contain 460 90% of non-missing values. Okay, so there's 1314 non-missing values. Okay, now just pass it. Let's say it's just x, and if you see the shape of x, what I'm doing, it's 17 column. See, the same thing we did before. Oh, we just again have to run our file because our data set is already dropped those missing values. Okay, now it's fresh one. Now let's use this one, x.drop and see the same thing, 75. So you don't have to use, you don't have to write these things. These are now unnecessary, but writing those things are actually good for you because it increases your productivity. Because some case you don't, maybe you don't have such parameters, built-in parameters, so you have to write or manually replace them. So it's good to practice such things other than using just these parameters. Okay, now we have dropped our unnecessary columns. It's time to impute or replace missing values. So before replacing missing values, you have to know why those values are missing. And if you have a data set, you can see the metadata for the description. What does those missing values mean? Why they are missing actually. Okay, so now let's see our missing columns now. Shit. Yes. Now again, if we run it, okay. Now you can see our missing columns. Garage type, year built, these are missing. Now you can drop all those missing values by rows, like df dot drop na. Okay, now you don't have any missing value because you just dropped some columns with rows. Now df dot is na dot sum 0 0 0. You got no missing value. Or you can use some techniques like this garage type, garage finish. These are integers, sorry, string values, so you can't use like mean method. You can fill them by forward fill or backward fill. So you can use these methods for string values, or mean mode for integer values. That's up to you. Well, so far so good. Now we are going to talk about duplicates and how we can handle duplicates with using pandas. So duplicates are nothing but just the repeatedly occurring rows in your dataset. And before you feed your data into a model, you should drop those duplicates. Okay, now we are going to import our the first data set, that is water quality parameter. So pandas have df.duplicated method for identifying any duplicates. So it's the dup duplicated. Okay, so it will return a boolean false false. If there's any duplicate occur, then it will give you true. So dot sum. Okay, no, not duplicate. So let's make some duplicates in our dataset. And if you see here, our dataset contains 64 rows. So now we are going to add, let's say, first 15 rows to our data. So we will have some duplicates. So df.loc loc. Okay. So then what we want 0 to 15 rows and all the columns, and it is our okay. You can see we have 15, a total of I think 16 rows. So I want to add it, store it in another data frame df2. So now we are going to concat those 15 rows with our previous data set. So pd dot concat concat. Okay, it should be in another square bracket, sorry, parenthesis. So our data frame was df and comma df2, and this is our new data frame, new df. Okay, let's hit it. Fine. Now and wdf. Now you can see total of 80 rows. So we have added 16 rows. Now let's see duplicates. New data frame, new df dot duplicated. Oh, new data frame, new dot loc. Okay, so this returns us our data set. Those 16 rows, which are actually our duplicates, they repeatedly occur in our data set. Now it's time to remove them, drop them. So new data frame dot maybe drop duplicates. Okay, yep, so it dropped all those duplicates, now returning us our previous data, 64 rows. Now you can write here in place equal true. Okay, let's say our new data frame. Yep. So that's it. That's how you treat duplicates using pandas. Very easy one. So now we are going to talk about data joining. And if you're going to be a data analyst or scientist, whatever, we're going to use it, I think, a lot. Joining data. Okay, now I'm going to import some new datasets. Df pd dot read csv. Okay, and it is rain yearly. I think, yep, dot csv. And our another data frame, let's see first. So it's just a simple data set. We have year and for those time rainfall. Now we are going to import another one. Just copy it. Okay, so this is our another data frame. Previous one was temperature, sorry, rain yearly. This is temperature yearly. Okay, let's print this out. So you can see here common is year. First one is year by rain, and this one is year by temperature. So we would like to join them. So pd dot merge. So at first our first data frame, comma, our second data frame, then on equal on which column you would like to join them. So we have year in common for both data sets. That's why I'm going to pass year. Okay, then how, and how is, if it's, I'm at first we're gonna start off by just outer join, OUT outer. Okay, and we can store it in a new variable like just new data frame and df. Let's see this new data frame and df. Fine. Now you can see our year's rainfall temperature. Notice here a nan value. You will see nan values because we used outer join. Outer join means, if you think about set, it's union. That is, we are taking all the values of our second data set and all the values of our first data set. So there might be some readings for our first dataset that are not present in our second dataset. That's how we may have some nan values. But if we do inner join, then there will be no nan value because it checks dates which are in common. So it is intersection. Now there's no missing value. And you see this was previously missing. There's no, so let's see pd dot and the new data frame df dot is null dot sum. Is there any missing value? No, no missing value. 0, 0, 0. So that's it. That's all about joining. So inner join and outer join. Inner join is what? Just intersection. Those are common. And outer join is all. Okay. Now we are going to talk about tidy data. Tidy data. So it's really a important one in data pre-processing step. And I think in your data science journey you will maybe want to use this technique to pre-process your data. It turns out that there's some rules for making a table. So if you follow those rules or guidelines, your data pre-processing or visualization analyzing will be much easier and faster. And you can fit your model by easily by following those rules actually. So let's see those problems. So your headers, column headers, should not be values. It should be variable names. Okay, these are some problems actually, or these are some attributes of messy data. So now we are going to see something like that. A data set df file. Now you can see over here that this dataset contains columns that are actually values, not a variable name. And this dataset is all about religious groups and their income range. These are their income range and count number of people under those income range. What we are going to do is we are going to make a new column where all those variables will be. Okay, so let's see how can I do that. So for that, that's set. So df.melt, a method called melt. Okay, so at first is id vars. This id vars takes those columns that you don't want to change. So this religion column, I don't want to change it, so I'm just writing this religion. If you would like to take multiple columns unchanged, so you have to pass a list of names. Okay, so id vars. Now what? Now id, let's see what it takes. Id vars, value name, var name. So now you're going to write var name, that is variable name. Variable name will be income range. Okay, now there's another parameter called maybe value name. Yep, value name. Now you're going to pass it value name. Count number of people. So let's see. So what it does, this method, is all the columns that are messy are within this column, and all the values, that is those counts, number of peoples for those columns, are now in this count column. Okay, now you can easily analyze this dataset. Just you can import SNS and Seaborn and easily visualize this data and do some visualizations. Okay, so now we are going to see another dataset, that is our Ebola dataset. Ebola. Now over here you can see that Guinea, Liberia, Nigeria, all the country names are in different columns. So this dataset is actually really a messy dataset, and we would like to make a column where all the country names will exist. Okay, so again we are going to say df dot, that is Ebola, dot melt id vars. So we don't want to change what date, so list of names, date, and I think day. Okay, now what? Now variable var, I think, yes, variable name, value name. So var name, variable name is country. Okay, so values, value name. So value name will be what? These are, I just count. Okay, so we can store this data in a new dataset diff. Okay, print diff. Up smelt got an unexpected one. Value name, var name. What was that? Oh, value. Value name. Shit, man. Adverse are not present. Day. And day should be in capital letter. Okay, fine. Now you can see our country count. By the previous dataset, you can, if I say you, I want to see, I want to compare mean cases by country. So it will, by the previous dataset, you can't visualize that, but now you can do that. And notice here this country column carry three information. One is country name, another is cases, that is confirmed cases, I think, and another thing is deaths, number of people died by country. Okay, so now if you do something like df dot group by what, group by country, and you want mean dot plot, and I want my output on this count column, count. Okay, kind equal bar and fixed size 11 by 5. Okay, got it. So now over here you can see this, maybe this Liberia, pretty high amount of cases. And for this Liberia country, you can see deaths are also highest. Okay, this one is also pretty high. Okay, so by the previous format you can't do this thing. So I can talk more about this study data and some more visualizations, but it's actually another topic. Well, now in this section we're going to talk about some string manipulation techniques in Pandas. Okay, now this is our data set. Okay, df. Here you can see it's actually here's some player's name, the college, the birth date, weight, height, etc. If you see df.info, now you can see columns which are integer, which are object. Object means string, so height is a string and etc. All others are string. Okay. Now at the beginning I want to talk about a strip function, strip method. So what it does actually, if you write x is equal to a string like string string, and after that you can notice here this white space. Now you want to remove this white space, so what you have to do is x.strip st. Now you can see string. Now here there's no white space anymore. Now if you want to access a column weight, df weight wt, you'll see an error because we don't have, it's saying we don't have any column named wt keyword. But if you press one space here, then it will be okay. So sometimes it occurs. So let me just see our div.column CU. You can see all of them are okay, but just this weight, this column it contains one white space. So to remove this, what we will do is div.columns is equal div.columns.str. So now you can see we didn't use str here because it's just a string. So but here it's Pandas series object. So to access string operations in Pandas series object, you have to use this str accessor. So str.strip strip. Now let's again access that column df weight wt. It's okay now. So that's all about strip function. Now let's talk about splitting. So to split, let's say I want to split a date 29 9 204. Okay, so I want to split it dot split, and by what? I want to split it by those forward slash. So in a quotation, now see all the elements are splitted by this forward slash. Okay, you can also split like hey. Guys, dot split by that underscore. Now notice here it returns us a list, and you can access each of the elements of this list. Now you can see that hey is now zeroth index, and guys are index number 1. So if you just pass here in a square bracket syntax just 0, then you'll extract just hey, and if you pass 1, then the second element, guys. But to access that in Pandas series, you have to pass here dot str accessor. Okay, we'll see that in a minute. Okay. Alright, let's see how can I do this splitting in our data frame. Now over here you can see this height column. Heights of all the pairs are in 70 to 70 inches, but some of them are in feet. Now let's say I want to convert all the all the height units to inches. So 6 feet and 2 inches should be converted to what? To inches. So what we have to do is we have to multiply this 6 by 12 and add it and with this 2. Okay, now how can I do that? df dot height height dot str dot split, and we want to split it by this hyphen. Okay, now if you want to get the first one, it won't work. We have to again spice dot str. Now you can see the first column is just those feet and those inches. This is just 6 feet. Okay, now we can store it in a new variable, column name just df. Right, let's call it fit. Fine, and we want to convert the data type object to floating point. So as type what? As type np dot float. Okay, now for our second element, what we will do, just here, second one, and let's say it's inches. Okay, now let's see our df. First one is feet. Okay, but for inches column you can see so many nans because all the rows doesn't contain any hyphen, so there's nothing to split. That's why in inches column there are so many nan values. So if you just want to add feet column with inches column, it will return you so many errors, because like np dot nan plus 5, it will return another nan. So what we'll do is we will just fill those nan values by 0, then our multiplication will cause no problem. So df dot fit inch and ch inch dot fill na by what? By 0, and in place true. Oh shit, there is not inch. What's the problem? Inch inc, shit. Okay, it's looking out. Now what? Now we want to convert those 6 to feet to inches. So to do that we have to multiply them by 12. So how do we do that? Just only those 6 6 or 7 7, but not those inches 78 69. So to do that, df dot loc df what? It's in our feet column, fwt less than, let's say 10. There's no one 10 feet, but say for example, and we want it only for our feet column. Okay, so we want to replace them by what? Multiply them by 12. So multiply them by what? 12. Multiply and equal 12. Let's see. Fine. Now our df. Okay, now 6 feet is turned into 72 inches. Now our final step is just adding those columns So df height in inches is equal df dot fit plus df dot inch. Now you can see our conversion is successfully done. 72, 74. The same thing you can do more easily by, if you want to convert all the units to feet, what you have to do is replace this hyphen by just a point, floating point, 6.2. So now you'll see the replacing method in Pandas series object. So df dot height dot what replace. I first see general replace method. So you want to replace. Now here 6-2 is actually a string, a total string, one character. It's 6-2. We want to convert them by, replace them by what? Replace them by, let's say, 0, for example. So you don't have to write that str accessor here for replacing method. See, all the 6 to 2 is replaced by 0. Okay, but if you just want to convert it as type typ and p dot float, it won't work because there's some other feet. Sorry, yes, feet, 6 feet and 0 inch. It's not actually convertible. So if you want to replace just this hyphen by what? By this decimal point. Let's see how it turns out. It doesn't working. Now it's working, but not really, because this replace method can't find any hyphen. So to access that hyphen, you have to write that str accessor. Now it will work. Now you can say that hyphen is replaced by dot. Okay, so now we have just created that, and we want to store it in a new variable df, let's say just ht height. Okay, now all the values are in height format, and we want to df dot loc what df h height, those are greater than 10, we want to what? We want to divide them by 12. Okay, now this our new, we want to perform that program on a new column ht. Okay, let's see our data frame. This is pretty simple. Just by using 2 lines of code, we have transformed our all values, all height values, in feet unit. You can see. this 6 feet to just 6 feet to 75, 6 feet to 5. So now you can see that this method is a lot easier than the previous one, just 2 lines of codes. But there's another way of doing this for the previous one, that is converting all the heights to inches, that is using a defined function by this way. So this is our height to numerical, just feet, inches, and returning what? Feet are multiplied by 12 and adding them up with inches. And here another function for just what? At first we are going to try height is equal just integer of height, that is for those height values are already in inches, and if values are not in inches, if there's any exception, then we'll use this function. Okay, so let's talk about some other string operations. Now we want to talk about display name. It's player name or college name. We want all the players for college name Washington or Southern Louisiana. How can I do that? So it's pretty simple. df dot loc, then what? df dot college name equal, it's just a Boolean masking, college name Louisiana. Control V. Okay, let's see what it turns out. Okay, cool. We have just one player for that college name. The same thing we can do by our string methods, like dot str dot, and you can see all the functions for this str access by shift tab. Sorry, not shift tab, just tab. Here you can see case word, find all, upper lower. So you're going to use contain. Contains what? Contains Southern Louisiana. What? Oh, it returns Boolean. So what you have to do is just wrap up it by square bracket and pass df. Okay, the same thing that we found before, but this method can do a lot more than the Boolean masking. So let's say we want all the columns, all the college names that starts with S. So for that we will add one caret sign before S. Now let's see. Oh, many college. Southern Louisiana, Stanford, San Diego, many more. So you can't do this thing by our previous method. Okay, so we can do a lot more things by this string function. Okay, Control C. These are actually some of the regular expression functions. str.find all names that starts with S. Okay, that starts with S capital S. Okay, so it returns as list, and you'll see that by just dot sum. Oh, sorry, just S. All the names that starts with S and followed by any character and one or more time. So now you can see all the names that starts with S. And here you can also specify I don't want any white space in between. So all the names without any white space. Now you can see all the spaces are gone. It's just the first name. Likewise, you can do many more things by this find all operation method. Okay, now let's do something more. Let's see just how to find out the length of those words. Give it str.lam. Now it will give you just length of those words. That is, this is 11. This is what? 10, 22. That's what. Okay. You can also do a upper lowercase changes by just here passing UPP here. All of the names are now in uppercase. Okay, so now we are going to, I think, see the most interesting part of string manipulation using pandas. So we're going to use a new data frame, and this data frame here, this country with cases, contains actually three information. One is country name. Okay, another is cases, that is confirmed cases, and another is deaths. So maybe you want to make a new column where only deaths column will exist, and you want another column where only confirmed cases will exist. Okay, so how do we do that? So here deaths is not just only one single row, it's multiple row. That's for Mali, that's for every country. And if you see the unique values of this column, then you can see just def dot unique. Fine. So now you can see that's for every country. So how do we do that? So for that we will use regular expression method. So df Control C, df country dot str dot extract, and this extract method starts with a R syntax. Okay. Now in a quotation we are passing our arguments, like we want any word that starts with capital D followed by any character. It could be words or numbers, then anytime, one or more time. Okay, so let's see. So what it returns is you can see now all the rows with that D, and I want to add it to my data frame as a new column, that is dead. Fine. Let's see our data frame. Yep. So this column contains only date cases. Fine. Now we want to make another column what will contain only what cases. So don't need to make another just extraction. We can just remove those dates from this country with cases column, then it will be only just confirmed cases. So how can we remove or replace all those dates by just nan values? So we can use that by replace method df dot what df then okay dot replace. So what you would like to replace? I would like to replace any word that starts with D. So any word that starts with D followed by any character and one more time. Okay, by what? By np dot nan, and so we have to write this regex equal true. Okay, so let's df.country with cases. Let's see this at first time. So now you can see cases, but no death column, death row. Okay, so we can update this column or just name it another column, like what df only cases. Now let's see our df. So these are cases, just only cases, no deaths. So I think there's no other way for doing this same task that fast without using this regular expression. And here you can just use also dot str accessor, then you don't have to use this regex equal true, and I guess you have to write this np.n within quotation. Both will do the same thing for you. So now we are going to talk about time series data. Time series, some date-time operations with pandas, which are pretty common in data analysis tasks. Okay, so at first we're going to start off with just importing our pandas document. Okay, as we always do. Okay, fine. Now we are importing our data, which is actually flights data for two different runway. Okay, so here you can see this unnamed column contains time series data, and now we can't do any date-time operations on this time series data because it's not actually converted to date-time data type. Now if you see df.info, you can see that this unnamed column, that is time, it's object, pandas object, so that means it's a string now, so you have to convert it into time series format. So what you can do is just pass here parse dates to true. That is, we are telling pandas that if you have any date time column, then use it or treat it as a time column. So let's see what it turns. Still object. Now it sometimes works, sometimes doesn't work. Okay, let's do index column is equal 0. That is, we want this column as our index. Let's see. Now you can see it's really in time series format. Div dot index. You can see d type, as data type is date time now. So you have to convert it into a index column. But sometimes, always, we don't want our date time column to be our index column, or we maybe don't want it. We want it separately as a time series column. So what we can do for that is we're just showing it by using another data, portfolio data df2. Let's say we did everything here, parse dates true, index column is 0, but still it's not in time series data format. Say index df2 dot index, it's still integer format. So Pandas gives us pretty quite useful libraries by which we can transform it into datetime data. So what we have to do is df.index is equal, or use any column name, is equal df dot pd dot to datetime, and within this parenthesis what you have to do is you have to pass the column name you want to change. So it's df.index, and here you can pass the format. What do you want? We want at first our year 1926, then month format. So what you have to do is %sign year. Sorry, you have to provide it within comma quotation. So %sign year. You can use this hyphen, maybe you don't know, it's not a problem. Hyphen and again %sign month. Okay, and if you have any day column, then you can specify another thing is like %sign day. We don't have any day in this data, so just this thing. Okay, now let's see our df.index. See, it's now datetime format, which is pretty useful. You will use this format, I'm pretty sure. I think you'll use it. Okay, now we are going back to our previous data, that is df, that is flights data. Okay, now what? So there are many things you can do with this datetime column. Now let's see what df.max. Let's see df.max. So for this airport maximum was 35, minimum, and for ORD it was 110. Okay, now if you want the index, or actually date for that maximum value, you can pass just idxmax. See, now this is the date when maximum value or maximum number of passengers occurred. Okay, now you can also see the date name. So what you have to do is dt dot what? dt dot day name, day day underscore name. Let's say, so it was Friday, Thursday. Okay, and now if you make this time column to your index, there are many convenience for that, because if you do that, your plotting will be easier, and you can subset your data by time without writing any Boolean indexing explicitly. Like, let's say if you want your data for just 2000, see all the data that I have from the date year 2000, and you can also pass a range of time like 2000 to 2005. Okay, but year 2005 is out of range, so I think I don't have 2005. Oh yes, I have. Oh shit, I provided extra 0. Okay, now that's it. Now if you would like to retrieve those years, days, months separately from this data set, you can do that pretty easily, just like what? df.index dot year, year, by this thing. Now let's see this. See, now here are all years from this data set. You can also extract all days, day, day 11131, and if you pass here time, just time, it will provide you or return you this time extension 23, 22, those things. Okay, now you can add these to our data frame. You can make a new column like df column name day. Okay, now let's inspect our data frame. See, it added a new column to our data frame. This was the first day, day 1, and it is 31st, so 31st. Now you can also transform this whole column to just day names, but okay, let's see how can we do that. We want a column by just day name. Okay, so our new column name will be df day name. Okay, is equal to df dot day dot dt. We have to use this dt accessor because we are using that date time day name method, and day name methods are not available for just a series. So for a series, if you want to access that method, you have to use this dt accessor, dt dot day name. And guess what? It will return you an error because our day column is not a date time column now. It's now just a, I think it's now a integer. So let's see what it returns. Where is it? Oh, what it did? Well, here it is. See, it's saying can only use .dt accessor with date time like values. So we have to convert that column, day column, to date time. Okay, so now what we'll do is df dot day is equal to pd dot to date time. The same thing we did before. This pd dot to date time, and here we'll pass again our column name df dot day and format. For format is I just want day. So percent percent sign and D. Okay, let's see. Yeah, it worked, I think. Div. Yes, it worked. Now you can see day and then Monday, Wednesday, Monday. Yeah, it's pretty cool. Okay, there's another datetime functionality in Pandas called period, and which allows simple arithmetic operations, just subtraction, addition, that's such things. Okay, what you have to do is div dot index is equal again div dot index dot to period, and here you have to specify which granularity you want. If you want daily data, or you can pass D. If you want monthly, that is our finest data. Which one you want here? Year and day, or year and month? Which one? If you do this to period M, then let's see what it returns. Now div. See, now here's only our monthly data, 12. And one advantage of this is you can add some new dates. Now you can just add months. Div dot index. What I'm doing? Index plus 5. So you can see our first month was 1, and here last one 12 and 1. So if we add 5, see what happens. Now our first month is 6, and here 5, here 6. Pretty useful. And if you pass this to day, oh sorry, it's actually done. So to do that you have to again refresh it. Okay, now if you want to add days, increment the day. Now if you add 5, then our dates will be changed. See, here it is 31st. Okay, now it will be 6. 31st 5, yes, 5 and 1 is 6. Okay, so that's all about those period type, and now we are going to see some plotting with sample moving average. So div dot plot. Oops, you can see this is really a very dense data set. Now we want to import our matplotlib. So let's see now. Yes, so this data is very dense. Now we will resample it to make it visually more intuitive, appealing. So div dot resample, it's somewhat like groupby method pandas. Div dot resample by what? Daily, monthly, anything you want, and you have to pass a method, otherwise it will not work. So I want daily, what? Daily customers sum, how many total for one day. Div dot sum, okay, daily. Now you can see this is our daily total number of passengers for each of the platform. Fine, now you can plot it also if you would like to. Div dot daily. Now I can say day. Now day dot plot. See? Now it's our daily sum. This is lowest value, maybe this one. And this is actually interactive plot. We used notebook, matplotlib notebook. That's why. You can also zoom it. Let's see over here. This data is very dense because we are using daily data. If you do it to weekly, then it will have lesser amounts of noise. See? Real less. Cool. So if you don't pass any sum or mean method here, daily you can mean and then it will not work if you don't pass any mean or sum method. Okay, there's another thing you can do is using aggregate function. You can pass more than one methods at a time. So it's dot aggregate, and within this parenthesis we want list of names. So one is mean, another is, say for example, standard deviation. Okay, min max we don't want that much. So now let's see our day. Now see, you have weekly data now. So let's see daily data. Now you have daily, mean and standard deviation for each airport, and this one seems to be good, though it contains a high standard deviation, but if it's positively skewed, then good, I think. Okay, now you can plot it, dot plot plot. See, very quite useful. Now there's another method is called rolling mean. You can apply on time series data to visualize it more or see the trends more clearly. So daily data, day dot rolling mean, rolling sum. At first we see our day. I don't want those mean. I just want, let's say, daily sum. Okay. Now let's see our data day. Fine. Now we want our rolling mean. So rolling mean does what? If you use rolling mean 2, let's df dot day dot rolling or rolling mean of 2 days. That is, we will use this first 2 value and compute their mean at first, and we'll have 1 value for this data, this date. Our first one will be missing. Okay, after that we will use the last one and then forward one and compute their mean again, the last one and forward one. So let's say df.rolling2.mean mean. See, first one is missing, so we have rolling mean of 2 days. So if you want it for 10 days and plot it, because we're using matplotlib notebook, you have to use plt dot figure. Okay, now you can see. Now you can see the trend Okay, and it's interactive. You can see dates. You can also use what rolling mean of 25 days, or maybe let's say 40 days. Now our data will be more sharp, more smooth. That's it. So that's all about rolling mean. Now it's time to talk about time delta. Time delta is nothing but just difference of two dates. It's just difference or just some arithmetic operations with two date time data. Like you have a data pd dot timestamp sta 3 4 20 10. Okay, another is b is going to pd dot timestamp, so it's 3 2 2010. Now if you subtract a to b, you can say, oh, so it is 3 2 4. Oh shit, it should be within comma condition. Now let's see, 2 days. So from this to this there are 2 days interval. So now we are going to see that this time delta operation by using a dataset. Fine, so let's see this data. So here we have parsed our these dates, departure date time and arrival time, to time date time data type. This is our departure time, arrival time, and now this is our departure time. And here is our arrival delay and the departure delay. So this is the time when a plane should arrive or supposed to arrive, and this is its delay. So we want actual time of arrival. So for that, what you have to do is time delta calculation. So I am going to create one new column, df flights ds flights dot new column is what? New column is our, let's say just want deal with arrival. So arrival delay time delta, arrival delay delta td time delta, okay, is equal to pd dot to time delta and within parentheses name of the column arrival delay, and then you have to specify unit, and here I think it's arrival delay, it's in minutes, so we'll use minutes, minute, okay, or you can pass t, just same thing, flights dtd. Okay, let's see, yes, it works. Now let's again see our df if flights arrival data. Fine, you can see if it's 12 38 23, and we want to add what arrival data 13 13 9. So how can I do that? So now it's if plus that time delta. Let's see. Yeah, it quite successfully worked. 38 plus 13, 51. 23 plus 13, 36. Then 33. Yes. Now if you want to increase it or increment it with hours, then here you have to pass here is hour. Okay, so that's how we do time delta using a real-time data set. And you can do many more things learned from Pandas data documentation. Alright, so that's all about this Pandas complete tutorial. If you have any question or any recommendation, let me know in the comment section down below. And if you find this video helpful, please subscribe, and I hope I'll make some other video on complete data science with Python. So I think I'll see you in my next video. So thank you.